Hey guys, Mr. Zigner here. We're at lesson 2-8. Today we're dividing with integers. So three things we're going to be looking at here today. We're going to divide integers with different signs, dividing integers with the same sign, and then we're going to look at all the operations involved with our integers at the very end. So first of all, we're dividing with different signs. So that means one of these numbers is going to be positive, one number is going to be negative. Now what do they say about that? Well, the quotient is when you divide, of two integers with different signs is going to be negative. So that's why we have a -3 here. 33 divided by -11 is -3. And of course right here we have a -64 divided by 8, which is positive, and that's going to equal a negative. So each time we end up with negative answers whenever the two integers you're dividing have different signs. And here's our first example, 36 divided by -9. Well, let's see, 36 divided by -9. Well, 36 divided by regular old 9 is 4. But would this be a positive or negative? Well, as I said earlier, when the signs are different, here's a positive, here's a negative, then your answer is going to be negative. One little trick we learned in class was this triangle method. You put a plus sign at the top and two minus signs at the bottom. Now, the 36 at the beginning of the problem was positive, so kind of scribble that out or cover it up. The 9 we're dividing it by was negative, so scribble out or cover up one of your negative signs. Notice the only thing left is a negative sign. That means the answer is also going to be negative. Just a quick and easy way to, in case you're getting mixed up with your signs about an answer being positive or negative, that's just a quick way to get back on track. So here we have 45 over -9. Now that actually is a division problem. Division problems and fractions, same thing. So this actually means 45 divided by -9. Again, we have two different signs, so right away we know the answer is going to be negative. And now all we have to do is figure out what's 45 divided by 9. Well, if you know your 9 times tables, you'd know right away that 5 is how many times that 9 goes into 45. But of course it would be a -5. All right, let's keep moving. Here's our other one. So now the quotient, again the answer when you divide, of two integers with the same sign is going to be positive. So here we go. 15 divided by 5, again a positive, divided by a positive, whoops, a positive, is going to also equal a positive answer. That hasn't changed since you were little. And now we have one, oh now look at this. Do you see what I see? This problem is all messed up. -64 divided by +8 is -285. This is messed up. It's supposed to be an example of a division problem with two integers that have the same sign. The book messed up here. I'm going to make a new problem. So let's call it -64 divided by, now with the same sign, that would be a -8. There we go, that's something that works. Now, how many 8's go into 64? Well, the answer is 8. Would it be positive or negative? Well, since these numbers have the same sign, it would be positive. Interesting error there. Here's one for us to do, -24 divided by -8. Well, we have the same sign, so our answer must be positive. All we have to figure out is what's 24 divided by 8. You might want to turn that around and use multiplication. 8 times what is 24? Did you figure it out? It's 3. 8 times 3 is 24. So therefore, -24 divided by -8 must be +3. Now we're doing a little bit of algebra. All that algebra means is we're simply putting the value of a variable into a problem and solving it. So we have g divided by h. G is 21. We're dividing that by -3. Oh, look at that. Our signs are different. Therefore, the answer must be, do you remember? One number's positive, one number's negative, so the answer must be negative. Different signs, the answer is negative. Now all we have to figure out is 21 divided by 3. Flipping that around using your 3 times tables, well, 3 times 7 is 21. So this answer must be -7. Some weather changes here. The temperature at 4 o'clock, let's start writing this down, 4 o'clock was 52 degrees. And then at 8 p.m., it is 36 degrees. What is the average change in temperature per hour? Oh, interesting question here. I see where the division's coming. It's right here. Change in temperature per hour. You may not know this yet, but per means to divide. So we're supposed to divide the change in temperature by the number of hours. Okay, let's figure out those numbers. Well, let's see. Over here, it looks like 4 hours went by. And over here, we went down a total of, let's do our subtraction here. That would be a 4. This would be a 12. And now 12 minus 6 is 6. And 4 minus 3 is 1. So we dropped 16 degrees in 4 hours. Dropped 16 degrees in 4 hours. So if I divide those 16 degrees that went down by 4 hours, I should figure out the change in temperature per hour. Here it is, change in temperature, and then the number of hours. So let's see. Well, -16 divided by +4, that answer is going to be a negative. A negative divided by a positive is a negative. The signs are different. That answer is negative. And of course, 16 divided by 4 is 4. So there it is. It dropped 4 degrees per hour. And moving on. Here's our summary. So you can see we're going to look at how to add, subtract, multiply, and divide with integers. So let's go back over these rules. So the first rule is with adding. 2 different things to keep in mind. If you have the same sign when you're adding, just simply add them together. And the sum is going to have the same sign as the integers. Okay, so if I had -7 plus -3, well, you just add them together. That would be 10. But since both numbers are negative, your sum has the same sign as the integer, so that'd be -10. Okay, there we go. That's pretty good. Now, different signs. When you have different signs, we're actually supposed to subtract. And the sum is going to have the sign of the integer with the bigger absolute value. Now, what does that mean? Well, let's look at an example and see if we can figure this out. How about I use some of the same numbers? So -7, but this time I'm going to add +3. All right, there we go. We're adding. Signs are different, though. All right, so what am I supposed to do? Subtract those absolute values. The absolute value of 7 is 7. The absolute value is 3. Of 3 is 3. Now I'm going to subtract. So 7 minus 3, what's that? 4? Now all I have to do is figure out, would that be positive or -4? Well, it says the sum has the same sign as the number with the greater absolute value. Well, which number had a greater absolute value? Well, 7 is bigger than 3, so 7 has the greater absolute value. But the 7 was originally negative in the problem I created. That makes the 4 negative. And there we go. So that answer would be -4. And that's how that rule works. Now the subtraction rule. To subtract an integer, add its opposite. In class, we called this keep, change, change. KCC. So we're going to keep that first number. We're going to change the sign to minus, from minus to positive, a plus sign, and then we're going to add the opposite of that second number. So let's make a little problem here. How about, oh goodness, how about 5 minus -4? All right. So we keep that first number. How about a 5 there? Now we change our sign to plus, and then we change the second number. That's a -4, so it becomes a +4. And of course, 5 plus 4 is 9. There we go. So you can see I just added the opposite of the second number. So 5 minus -4 became 5 plus 4. Add the opposite of the second number. Now our multiplication and division rules. Well, basically they're all the same, and I've just reviewed those, but let's go through it one last time. In any multiplication or division problem, any multiplication or division problem is going to follow these rules. So if they have the same signs, doesn't matter if they're both positive or both negative, you're going to get a positive answer. So let's just maybe make a multiplication problem. 7 times 3. Well, 7 times 3 is 21, but guess what? So is -7 times -3, because their signs are both the same. They're both negative. So it doesn't matter if it's +7 and 3 or -7 and -3, you're going to get that positive 21. Now, on the other hand, if you had a +7 and a -3, well, now you're going to get a -21 because our signs are different this time. So you're going to get a negative answer. Now we can, of course, flip that around and use division. How about 21 divided by -3? Well, again, we have different signs, so you're going to get a negative answer. But as soon as I make both numbers negative, -21 divided by -3, now I'm back to a positive answer. Again, that would have the same signs, so that product or quotient would be positive. All right, well, I think that's the last slide. Yep, the end. So thanks for joining me on lesson 2-8, dividing integers. We'll be having a test coming up soon. Please review vocab and all your worksheets, our notes, our foldables, and get ready for that test. But for now, there should be a set of questions on my website for you to complete, and we'll see you guys soon. Thanks. Bye-bye. Thanks for joining me as we work our way through the 7th grade Math Connects textbook. Feel free to email me with any questions. My website is www.mattzigner.com. On my site, you'll find links to my math blog, some of my favorite educational sites, and lots of helpful information for students, parents, and teachers. See you next time.